Hi everyone. Today's topic is quantum numbers. Generally, these quantum numbers are proposed to explain the arrangement and movement of the electrons in an atom. That means how the electrons are arranged in the atom, how the electrons are moving in the atom, and where they are located. So, like that. To explain the arrangement and movement of the electrons in atom, the quantum numbers are proposed, and also these are explained polyelectronic atom spectral lines also. Generally, the Bohr theory explains only single electron atom spectra, but the quantum numbers will explain the spectral lines of the polyelectronic atoms. And there are total 4 number of quantum numbers. One is the principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So principal quantum number can give the information about the main energy level. Main energy level is nothing but where the electron is revolving around the nucleus. It is called orbit. And azimuthal quantum number can give the information about number of sub energy levels in a main energy level. These are called orbitals. And magnetic quantum number can give the information about the orientation of orbital. And spin quantum number can give the information about spin of the electron. First, let us come to principal quantum number. A principal quantum number is nothing but main energy level. So, according to the Bohr theory, the electrons are revolves around the nucleus in a certain orbit. For example, if you take the Bohr theory atomic model, so this is the nucleus, and when you take the atom, around this nucleus, the electrons are revolving in a certain orbits. So, these orbits are called principal quantum number. These are also called main energy level. So, where the electrons are locating or where the electrons are revolving around the nucleus. So, that is called principal quantum number or main energy level. So, generally, the principal quantum number is denoted as n. The n values will be 1, 2, 3, 4 like that. So, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Or it may be denoted as k, l, m, n also. That means if n is equal to 1 is denoted as k, n is equal to 2 is denoted as 2, 3, m, 4, n. So that means it will be written as 1, 2, 3, 4 or it will be written as k, l, m, n, o also. And generally the principal quantum number can give the information about the energy of the electron. So when the electron is revolving around the nucleus in a certain orbit, when it is present in the orbit, so what is the energy of that electron? So that will be explained by using the principal quantum number. And these formulas are used to find out the energy of the electron and the radius of the orbit. To find out the energy of the electron, you are using the formula E is equal to minus 13.6 Z square by N square. There Z is the atomic number of the atom and N is the principal quantum number. And the radius of the orbit is calculated by using the formula R is equal to 0.529 into N square by Z. Same thing here also, N is equal to principal quantum number and Z is equal to atomic number. So this is about the principal quantum number. That means it is giving the information about the main energy level. So where the electron is located. So in the main energy level where the electron is revolving around the nucleus. So that information you will get by using the principal quantum number. Let us come to azimuthal quantum number. So generally the azimuthal quantum number can give the information about the sub-energy levels. These are also called orbitals. That means the number of sub-energy levels present in a main principal quantum number. So in the main principal quantum number, how many sub-energy levels are present, that will be explained by using the azimuthal quantum number. So generally the number of sub-energy levels will be equal to 0 to n minus 1. The number of sub-energy levels present in a main principal quantum number n will be equal to 0 to n minus 1. So what is the meaning of this one? For example, let us take first principal quantum number n. So the L value will be 0 to n minus 1. So here n is equal to 1. So that means 1 minus 1. The total value you will get only 0. So that means if the principal quantum number 1, the sub-energy levels present in that one is only 1, that is called 0. And if the principal quantum number is 2, in that it is having the 0 and 1. So n minus 1, 2 minus 1. So the maximum value will be 1. So the total values of the L is 0 and 1. The principal quantum number 2 contain the two L values, one is the 0, next one is the 1. And if the principal quantum number 3, it contains the three L values 0, 1, 2. Same thing here also. So 0 to n minus 1. 0 to n minus 1 means here n value is 3 means 3 minus 1. The maximum value will be 2. So that means here 0, 1, 2. So the principal quantum number 3 contains the azimuthal quantum number 0, 1, 2. Similarly, when you come to principal quantum number 4, it contains 0, 1, 2 and 3, like that. So depends upon the principal quantum number, you are getting the azimuthal quantum number. That means it is giving the number of sub-energy levels. These are also called orbitals. So principal quantum number 1 contain the only one sub-energy level. Principal quantum number 2 contain the two sub-energy levels. Principal quantum number 3 contain the 3 sub-energy levels, and 4 contain the 4 sub-energy levels. And these sub-energy levels are called orbitals. According to this L value, we will get the shape of the orbital also. When you come to the shape of the orbital, the s orbital, what is the s orbital? If L is equal to 0, that is called s orbital. If L is equal to 0, that is called s orbital. It present in the spherical in shape. If L is equal to 1, p orbital, dumbbell shape. If L is equal to 2, d orbital, double dumbbell shape. If L is equal to 3, f orbital, fourfold double dumbbell shape. So like that, according to the L value, we are getting the shape of the orbital. The magnetic quantum numbers can give the information about orientation of the electron in the space. That means how the electron is oriented in the given space, that will be explained by using the magnetic quantum number. And generally the magnetic quantum number will be depends upon the azimuthal quantum number. So depends upon azimuthal quantum number, the orientation of the electron will be there. And generally the relation between the magnetic quantum number and azimuthal quantum number will be m is equal to minus L to 0 and plus L. These values will be from minus L to plus L, including 0. If the m is equal to, depends upon the, what is that one L value, we are writing the m values. For example, if the L is equal to 0, already know that one. If the L is equal to 0, that is called s orbital, the m values will be 0 only. Because the m values, what is that one m values? M is equal to minus L to 0 and plus L. That values will be minus L to plus L. So if L is equal to 0, the m value is also 0. And if L is equal to 1, already know that one. If the L is equal to 0 is called s orbital, it contains only one type of the orientation. And if L is equal to 1, it is called p orbital. When it is L is equal to 1, m values will be minus 1, 0 and plus 1. Minus L to plus L. So that's why if L is equal to 0, m values will be minus 1, 0, plus 1. That means this orbital contains the three types of the orientation. Those are called px, py and pz. The orientation of these orbitals px, py, pz. And similarly, if the L is equal to 2, it is called d orbital. The orientation of the orbitals are 5 types. M is equal to minus 2, minus 1, 0, plus 1, plus 2. Like that. So when you come to these m values, the m values will be depends upon the L value. So if L is equal to 0, s orbital contains only one orientation. If L is equal to 1, p orbital contains 3 orientations. Minus 1, 0, plus 1 are called px, py, pz. L is equal to 2, d orbital contains 5 orientation, that is minus 2, minus 1, 0, plus 1, plus 2. And these are also known dxy, dyz, dxz, dx square, y square and dz square. So like that, you can get the, what is that one, the m values depends upon the L value. And here you will get, if principal quantum number is equal to 1, the L value will be 0 and m value is also 0. If the principal quantum number 2, the L values are 0 and 1. So what is the L values here? So that is 0 to n minus 1. The L values will be, so 0 to n minus 1. And the m values will be minus L to 0 to plus L. So like that, if n is equal to 1, you are getting the L values 0, M values 0. If n is equal to 2, L values are 0 and 1, s orbital, p orbital, it is having the 0, minus 1, 0, plus 1. If n is equal to 3, L is equal to 0, 1, 2. So the M values are 0, minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1, plus 2. Like that. So depends upon the n value, we are getting the L values, and depends upon the L value, we are getting the M values. And next let us come to spin quantum number. So generally the spin quantum number can give the information about the spin of the electron. So in any given orbital, the electron is having the two types of the orientation, that is called spin. So it may be present in the, what is that one, clockwise direction, or it may be present in the anti-clockwise direction. So generally if it is having the clockwise direction, that is called spin of, is written as plus of, and if it is having the anti-clockwise direction, it is called spin down, it is written as minus of. That means, so this is the plus of and this is the minus of. So that means according to the spin quantum number, electron is having the only two types of the, what is that one, orientation, that may be spin up and spin down. So the spin up will be written as the plus of and spin down will be written as minus of. Okay, next come to summary of the four quantum numbers. First, principal quantum number. The principal quantum number will be denoted as n, and the values of the principal quantum number is 1, 2, 3, 4, 5 like that. And the principal quantum number can give the energy of the electron and radius of the orbit. So it will give the size of the orbit and energy of the electron. And the second one is the angular momentum quantum number is denoted as L, and it is depends upon the n values. The L values will be from 0 to n minus 1, and it will give the information about the shape of the orbital or subenergy levels, that is the number of subenergy levels. Let us come to magnetic quantum number. It is denoted as M or ML. These values will be depends upon the L value, that is the angular momentum. So these values are from the minus L to 0 to plus L. It will give the information about the orientation of the orbital in the space. The spin quantum number is denoted as ms or s. It is having the two values, that may be plus of or minus of. Plus of is the spin up and minus of is the spin down. And it is giving the information about the spin of the electron. Next we come to the calculation of the number of subenergy levels and number of electrons in any given orbit. So here you can calculate the number of subenergy levels by using the n square formula, and the number of electrons present in the main energy level by using the n square formula. For example, let us take the principal quantum number 1. What is that one? If the principal quantum number is 1, the number of orbitals. So what is the number of orbitals? That will be calculated by using the n square. That is 1 square equal to 1. So what is that one? It contains the only one orbital, that is called 0. And it contains 2 electrons. The number of electrons will be calculated by using the formula 2n square. So 2n square, the n value will be 1. When you substituting the 1 here, 2 into 1 square, you will get the 2. Similarly, the principal quantum number 2, the number of orbitals, total you are getting the 4. How you are getting the 4? One orbital is the, what is that one? 0. Another orbital is the 1. So 1 is nothing but it is a s orbital, and 0 is nothing but it is s orbital, and 1 is nothing but it is p orbital. So p orbital contain the px, py, pz. Like that you are getting the total 4 orbitals. 1 s orbital and 3 p orbital. Total together you are getting number of subenergy levels are 4. And 4 orbitals contain the total 8 electrons. Same thing here also, the n value is 2. When you are substituting the 2 value here, you will get the 2 into 2 square. So 2 square 4 into 2, you will get the 8 electrons. And similarly, let us come to principal quantum number 3. The total number of orbitals or subenergy levels are 9. How we are getting the 9? Total number of orbitals. Same thing here contain the 0, 1, 2. 0 is the s orbital, and 1 is the p orbital, and 2 is the d orbital. S orbital is 1, p orbitals are 3, and d orbitals are 5. 5 plus 3 plus 1, total together you are getting 9 sub-energy levels. These 9 sub-energy levels contain the total 18 electrons. Similarly, principal quantum number 4 will get the 16 n square. So 4 square you will get the 16 sub-energy levels and it will accommodate the total 32 number of electrons. By using these two formulas, n square and 2n square, you can find out the number of sub-energy levels present in a main energy level and number of electrons present in that same energy level. And let us come to total overview of the 4 quantum numbers. So this chart will give the number of, what is that one, principal quantum number, azimuthal quantum number, magnetic quantum number and spin of the electron. According to that one, what is the orbital and orbital name, number of electrons present in that orbital and total number of electrons present in the main orbit. Let us come to principal quantum number 1, n. So the L value will be 0, m value is also 0. So when it is having the m value 0, it may contain the 2 electrons, that may be plus of or minus of. So number of orbitals in that one is 1, that is s orbital. So orbital name is 1s. Number of electrons present in that one is 2. Total number of electrons are 2. That means principal quantum number 1 will accommodate only 2 electrons and it contains the only one orbital. It is called 1s. Principal quantum number 2 contains the total 2 L values. One is the 0, next one is the 1. So when L is equal to 0, the m value is also 0. When L is equal to 1, the m values are minus 1, 0 and plus 1. The 0 accommodate the 2 electrons and minus 1, 0, plus 1, each one accommodate the 2 electrons. And the number of orbitals present in this one is 1. The number of orbitals present in this one is 3. And this orbital is called 2s and this orbital is called 2p because the main principal quantum number is 2. So it is s orbital. That's why it is called 2s orbital. The main principal quantum number 2 and it is called p orbital. So L is equal to 1 means it is p orbital. That's why it is a 2p. 2s and 2p. And s orbital accommodate 2 electrons. P orbital accommodate 6 electrons. Total main principal quantum number 2 accommodate the 8 number of electrons. Similarly, let us come to principal quantum number 3. It is having the L values are 3, 0, 1, 2. 0 is having the m value is 0. 1 is having m values 3, minus 1, 0, plus 1. And 2 is having m values 5, minus 2, minus 1, 0, plus 1, plus 2. Same thing. Every orbital accommodate the 2 electron. That's why they are having the spin quantum number plus of minus of. And the number of sub-energy levels present in the O is 1 and P is 3 and D is 5. And this orbital is called 3s. The main principal quantum number 3. So it is s orbital. That's why it is called 3s. And it is 3. It is p orbital is called 3p. It is 3. It is d orbital is called 3d. 3s orbital accommodate 2 electrons, 3p orbital accommodate 6 electrons, 3d orbital accommodate 10 electrons. That's why total together 18 electrons are present in the M shell. Let us come to advantages of the quantum numbers. So by using the quantum numbers, you can specify the exact location of the electron. That means in the atom, every electron is having its exact location. According to that location, you can write the, what is that one, 4 quantum numbers. And one more thing, no 2 electrons are having the same 4 quantum numbers. That is also one important point in case of the quantum numbers. And it will describe the energy levels and sub-energy levels. The quantum numbers are describe the energy levels and sub-energy levels. And also it is explaining the shape of the orbitals and orientation of the orbitals. And also it is explaining the electron spin and magnetism of the. Let us come to writing the 4 quantum numbers to a valence electron. Here I am taking one example, that is the sodium atom. To write the quantum numbers of any valence electron, first you have to write the electronic configuration of that atom. The electronic configuration of the sodium is 1s2, 2s2, 2p6, 3s1. In this, what is the valence electron? 3s1 is the valence electron. And how to write the 4 quantum numbers for this one? So here this value is the n. The 3 is nothing but n and s is nothing but L. According to this L value, we will get the m value. If L is equal to, what is that one? S is nothing but L is equal to 0. If L is equal to 0, you will get the M is equal to also 0. And it is having the 1 electron. Mostly when it is having 1 electron, we will write the spin of the electron is plus half. That means the 4 quantum numbers of this valence electron is N is equal to 3, principal quantum number, L is equal to 0, azimuthal quantum number, M is equal to 0, magnetic quantum number, and S is equal to plus half, that is single electron. Like that you can write the any electron quantum numbers. And when you take any electron, so no 2 electrons will get the same quantum numbers. That is the one point you have to remember here. Thank you.